Alright, so welcome to the video for lesson number 9, factoring by grouping. Before we go over the homework questions, I'd like to first take a couple minutes just to go through and look at the different factoring strategies we've learned throughout this unit. So first is difference of two squares. So difference of two squares, we need to have two terms, subtraction, and perfect squares. We've also learned the sum and difference of cubes. Again, two terms, perfect cubes. No sign restriction on that one. We've also learned trinomial, so three terms. Help to spell terms, right? We have the AC method, three terms, and x squared has a coefficient greater than 1. We have grouping, 4 or 6 terms. And last but not least, GCF. This can be any number of terms. Okay, so let's jump into homework. So the grouping homework actually wasn't too bad, very similar to what we did in class. So first things first, we want to group the first two terms from the second two terms. GCF of the first two is x squared, leaving us with x minus 6. Second would be negative 25, leaving us with x minus 6. Then if we go through and factor, x minus 6 times x squared minus 25. We can then keep factoring, so x squared minus 25 becomes x plus 5 and x minus 5. All right, for the next one, GCF of the first two is x squared, leaving us with 3x minus 5. Second two is going to be negative 16, leaving us with 3x minus 5. So we have 3x minus 5 as my common term, and we're left with x squared minus 16. Well, that's going to give us 3x minus 5, and then x plus 4, x minus 4. So notice we're using all of our factoring methods all together here. For the next one, again, break it apart. X cubed, leaving us with x minus 4. This is going to become 4x, leaving us with x minus 4. And we have x cubed plus 4x and x minus 4. Now, notice I forgot something. I kind of did it on purpose here to see if you noticed the same thing. There's a GCF of x in the first expression. Now, if I forget that, it's not a huge deal, right? I just have to see that there's a GCF here as well. So, because there's a GCF here, I can say, well, I could divide out x, leaving me with x squared plus 4, and x minus 4. Now, if I had divided out the GCF first, I'd wind up getting the same exact answer, so it really doesn't matter too much. Well, let's look at the next one, GCF of 2. 2x cubed plus x squared minus 18x minus 9. Break it apart. X squared, 2x plus 1, negative 9, 2x plus 1. So if I complete the factoring here, we have the 2x plus 1, and we have the x squared minus 9. Well, x squared minus 9 is still factorable. So I have 2x plus 1, x plus 3, x minus 3. Number 2, explain why we can't use grouping here. So it's 4 terms, so that tells me grouping. So let's start our grouping method. Well, geez, I keep hitting a button here, I think. All right, so if we start our grouping method, we get x squared, x plus 3. Well, if I divide out negative 2, that gives me x minus 3, so that's not good. If I did it again, but I did positive 2, that's going to become negative x plus 3. So essentially, I can't get these two parentheses to match. So what we can say is there is no GCF of binomials. Something along those lines. Showing that it can't happen is just as good. All right, so let's look at these last few. So these are some more difficult ones, only because there's more variables or more terms. Something happened here. So here we just have more variables, so we just have to do a little bit more thinking. X squared for sure is my GCF. So I have 6x minus 5y. Here, our GCF is going to be negative 4y squared, which is going to leave me with 6x minus 5y. Well, the 6x minus 5y is your common term, and we're left with x squared minus 4y squared. Well, that's still factorable. Difference of 2 squares, right? 2 terms, perfect squares. Gotta look for all that stuff. So I have x plus 2y, x minus 2y. For the next one, we have grouping again, 6 terms. Remember, 6 terms could either be broken apart into 3 groups of 2 or 2 groups of 3. I'm going to choose to go 2 each so that I can keep my exponents in the right pattern. So that's going to be x squared, x minus 3, negative 6x, x minus 3, and 8x minus 3. So that's going to have a common term of x minus 3, x squared minus 6x plus 8, which is still factorable because I know that negative 4 and negative 2 multiply to make 8, but add to make negative 6. The last one, I'm going to choose to go into 2 groups of 3, so that again my exponents stay in the right pattern. If not, we'd have weird like terms in different places. First 3 terms have a GCF of x squared, leaving us with 2x squared minus 7x minus 15. The last set of terms have a GCF of a negative 4, which leaves us with 2x squared minus 7x minus 15. So I have this 2x squared minus 7x minus 15 as my common term, and x squared minus 4 as my uncommon term. All right, so for that first parenthesis, we have to use that method of the AC method to try and multiply, or factor, sorry. So I have negative 30 as my common term there. What multiplies to make 30, but adds to make negative 7. So we could do 10 and 3. So I'd rewrite that as 2x squared minus 10x plus 3x minus 15. Well, that's going to factor to 2x, x minus 5 plus 3, x minus 5. So I'm going to wind up having x minus 5, 2x plus 3. And this term is going to become x plus 2, x minus 2, right? That's going to come down there. So that would be basically as difficult as I could make one of these. Hopefully this video helped. If you still need help, remember I'm after school for extra help, or just try and come and see me during a free period.